I want to talk to you about flash shield, metallically shielded flexible gas piping by Gastite. We introduced this product in 2010. It has a protective jacket on it, and the premise of the jacket is to improve the product's performance when it comes to lightning energy, getting in a house, and impacting corrugated stainless steel tubing. This product has a metal shield in it, which is a technology we borrowed from the aircraft industry, and it's a material they use to protect aircraft parts. So we incorporated this metal shield, wrapping around our gas piping to get the same benefit from the metal shield that the aircraft people seek and get. In April of this year, we're going to launch a new fitting for the flash shield product. Call it the XR3 fitting. It's in my hand. And it's going to replace the FS fitting that we marketed with the product originally. With the new XR3 fitting, there's a greater point in the bushing for contact with the metallic shield. And that greater contact point would allow electricity to flow through the shield and out through the fitting if the pipe would be energized, for example, by lightning energy coming into a house. So the bushing is really the change in the fitting. And with that change, we prep the end of the pipe in a way to bring the metal shield out, similar to the way a coax cable is prepped. So the metal shield can contact the bushing and allow energy again to flow better than our prior fitting. With that design, this product can withstand nearly 95% simulated lightning strikes in a laboratory. So to get to this end prep, there's a two stage of cutting and stripping. And to facilitate that, we introduced a stripping tool, or we're bringing the stripping tool out this April as well with the new fitting. The stripping tool is two-sided. Strips on one side, you do a secondary strip with the second side. It's indicated with a 1 and a 2 on the top. And strip 1 is also the smooth side of the tool, where strip and cut 2 is the side of the tool with the ridges. So I'll demonstrate how the tool works. Your CSST is going to be cut to length by the contractor in the home. You place the tool on the end of the tubing, side 1, the smooth end, and put it in until it reaches the stop point within the tool. And close the tool and rotate it several times back and forth, a little bit more than 180 degrees per rotation. You're cutting all 3 layers of the jacket at this point at the valley of the second corrugation. Open up the tool slightly to remove the layers of the jacket, and that now has removed the 3 jacket layers, including the metal shield, and you can see a little bit of the layers here. And then utilize the second side of the stripping tool with the ridges, close it again, rotate again, and this is just going to take off the outer jacket down to expose that metal foil, and that now makes the metal shield available to the bushing, which is going to contact it again, giving it great connectivity. The nut goes on as normal. The bushing has 3 ridges. The first ridge goes in the valley of the first convolution. Second ridge is the one that's contacting the shield. The third ridge is the jacket lock feature of the bushing. The bushing's in place. The adapter would already be screwed into your appliance or valve. Just insert the product into the adapter, pull up the nut, tighten the nut finger tight, throw the wrench on there a couple more times, and that creates your flare seat, and you're done. Again, I said we incorporated this from technology used by the aircraft industry. They use this metal shield, and they laminate it between composite parts on an aircraft surface. So if they need to flow electrical energy through an aircraft skin, it can flow through this metal shield, usually toward the tail of the aircraft, where it still may exit to Earth, if we're talking about lightning energy striking an airplane. We utilize that metal foil. Again, the entire product is wrapped in it. And if lightning energy should strike this product, some of it will spread out on the outer jacket with semiconductive polyethylene. That'll spread the energy out somewhat, but then the energy will connect with the metal shield, the middle layer. It'll move down the middle layer, and again, that's where we want to move it to the fitting. So it just doesn't move down the layer and jump up to the CSST. It's going to move to the fitting contact point, which is that second ring in the bushing.